Okay, this is Ray Fuga with Downstream. The title of this session is Illustrating Variants and Process Steps in Your Assembly Drawings and Using Blueprint to do that. Joe Clark, one of the founders here at Downstream, will be presenting our quote-unquote blueprint guru.
So, off we go. So this is about using Blueprint to manage assembly variants and process steps. I think the logical place to start is with some definition of terms to make sure we're on the same page. If I've learned nothing in my years in EDA and high tech, we have a lot of abbreviations and acronyms which we tend to use for multiple purposes, and I've been in situations where I've been speaking to an audience and everybody's shaking their head yes at me, but it turns out that oftentimes we're thinking about two different things. So an assembly variant, it's nothing more than a derivative of a master PCB assembly, i.e. all the parts that were included in the design and layout, to achieve different functional capabilities of the overall circuit. And we accomplish that by removing or changing components. It's the same printed circuit board, same layout, just different parts installed. And the variant components, the variables, can be marked or attributed or identified as installed, also known as populated, fitted, and there's probably even more terms for it out there, but those are the ones I hear most frequently. Not installed parts, also known as DNI, do not install, DNP, do not populate, and again, I'm sure there's more terms out there as well. And substituted parts. And substituted parts are the same footprint, but it's a different part with modified parameters or capabilities such as the value of a capacitor or a resistor, and so on. So that's what we mean when we talk about assembly variants. It's not a change in the design. It's just a different part configuration. Many of the CAD tools that exist in the market in the actual CAD system allow us to define these variants. And the reason why we do it in the CAD system is because that was always the best vehicle place to do it. And all we're really doing is creating the mechanism by which we can create a documentation layer which shows an assembly drawing with the different parts. To the best ability of the particular CAD system. Back in the day, when I first started, we didn't have that ability, and we had to actually color code hard copy assembly drawings. And you can imagine what that was like and what would happen if an ECO came along. So that's an assembly variant. It's not a design problem, it's a parts list problem. Now we move into process steps, and let's define that. A process step and assembly step, I'm sure there's other terms out there that companies use. It's basically a partitioning of the printed circuit board design to assign components that are going to be assembled or put on the board to a specific assembly station or step that's available or in our assembly flow or assembly process. Now, this can be true of, the need for this can be true whether we have a captive manufacturing facility or we're handing the manufacturing facility the data off to be manufactured external. Each process step, especially for the manual process steps, can be documented in a color-coded visual aid, a document sheet, for the assembly operator of that specific process step. In addition to that, I can also, for each process step, extract the centroid information, the XY location, for those parts that make up that process step. I may not need a visual aid if it's automated, though, final inspection and so on, these are useful. But what I'm really after is the ability to extract the information for the automated equipment to drive that particular step in the process. And in this slide here, we show a sample assembly process where step one is we do our solder paste, we put our top side SMD parts on, we reflow, we have to flip the PCB because we've got bottom side SMD. We then may do through-hole components and then go through wave and hand soldering. There may be an assembly process step. There may be multiple steps or equipment in a step, depending on how a company defines it, for SMT parts. It's all not just one machine. So every company is different, but we need to have an ability to identify these, create the visual aids, and extract the information we need to drive our manufacturing equipment. So that's terms defined, so you understand what we're referring to when we say here at Downstream, for the purposes of this presentation demonstration, and in general with our tool, what we mean by assembly variants and process steps. And of course, it can get complicated, can't it? Because I have a design which has full assembly, and I may have to create XY files to drive the process steps, my manufacturing flow, for that version of the build. Well, then I have assembly variants. And there's going to be some different components or components missing, and I need to be able to generate the visual aids and the XY centroid information for all those builds. And then you can take it one step further, and what about if I have this in an assembly panel, it's a 4-up panel or a 6-up panel, now I need to generate the process steps for a stepped-up assembly panel for this variant, and so on and so on. So it gets very complex. So let's start with assembly variants and just go over some of the highlights. Here's an example of a possible visual aid assembly drawing for an assembly variant. What we're showing here is PCB views. I have an assembly variant, double-sided board, top side components, bottom side components. So with uninstalled and substituted parts, I'm always going to want to show both sides of the PCB to identify what's installed, what's uninstalled, what's substituted. I also want to have a parts list that I can use as part of my documentation, or separately in an export that matches this assembly variant. I also show here, we can have as many views as we want. Maybe we only want to show the uninstalled. Maybe we want to always have a fully populated PCB view, but a parts list which is just the uninstalled or the DNIs or the do not install, or the substituted parts. The permutations are many and varied. So I can have as many PCB views as I want. This is just an example. In addition, I may want to show 3D versions of views of the printed circuit board, which greatly helps in actually really physically visualizing what this PCB looks like in its final assembly, because these parts are missing. With our new 3D capabilities and the elements and the models that we've added to Blueprint in the current versions, I can have 3D views of the PCB rotated in various ways and displayed as we've covered in previous sessions, also presented by assembly variant and by process step. Okay, so this is an example. We also have a legend for cross-referencing, user selectable, user definable, what colors or schema we're using to identify uninstalled parts, installed parts, and substituted parts. Okay. How do we create and manage our assembly variants? Well, at the core of the assembly variant capabilities of Blueprint is the variant manager. Now, in the variant manager, which is a dialog that I can call up, I can manually create by just identifying this part's installed, this part's uninstalled, substituted, what the substituted part is, and so on, and create as many variants as I want, and then display them, get the delta, the differences between various variants, and so on. But of course, if we have hundreds, thousands of parts on a PCB, we're not going to want to do that by hand. There's a far easier way, but we want to be able to display and manage these. So to front end, the variant manager is an import wizard. And this import wizard allows us to import, which is a very typical, desired, common method for dealing with assembly variants or parts lists, but specifically assembly variants, where typically companies prefer and have the capability to manage and define their assembly variants at the schematic level. There's really no need to go into the PCB. We did that because that was the vehicle historically, but now that we have a flexible tool that can deal with these kinds of issues, we take the information from the schematic singularly, i.e. assembly variant by assembly variant as a CSV Excel spreadsheet, or in its entirety. Here's the whole parts list, and here's all the variants with the substituted and the uninstalled information all in there. I can read that in through the import wizard, and Blueprint recognizes, okay, here comes the parts list. Oh, these ref designs are missing from the master. These part names or part types are different than what's in the master, and it understands and builds the variants and automatically identifies what's uninstalled, what's installed, and what's substituted. And when I have substituted parts, I could have a different set of attributes for that part, right? Different values, tolerances, and so on. Well, now that I've created my information, my variants in Blueprint, I've got the core design, I've got all this part information. Now I want to create my drawings, and I need some control mechanisms to specify how I want my variant parts list. So look, do I want to have fills, colors? Do I want to show installed, uninstalled, only substituted? Do I want to show in one parts list all of my variants in their own columns to the right or to the left of the parts list? So not only are there many ways to bring in and manage the assembly variants, but the choices and the flexibility and formatting and how you want to present it is unlimited. So that's assembly variant creation and management. Now let's take a step next to process steps. And similar to many tools in Blueprint, much of the functionality, there is a process step manager. I'm sorry. So now we're on. I lost my flow there. Now we're going to go over to the process steps, talk about the highlights, and then we'll talk about the tools. Same thing for the process steps. Just like with a PCB view or any PCB document, 2D or 3D, I can have as many PCB views as we're showing here as I wish for whatever my particular purpose is. Here, again, I'm showing a 2D view of a process step. These are the parts, color-coded, that get installed in this step in the process. My step one at my company, ABC, is a chip shooter, and this is what I'm doing on the top side. So I'm showing a top side view. I'm showing the top side view because I'm doing one side at a time here before I flip the board. I also can show that in 3D. And here's a color-coded parts list, which, again, for a visual aid is very helpful. But if this was a manual process step, this would be extremely helpful to the person who actually has to physically install certain parts. Where do they go? Where do they go in relation to other things on the board? and you have choices in terms of how you want to display that. So there's unlimited PCB views, full customization of those PCB views in 2D and in 3D, with all the visibility and color control that we would expect to go along with that. That color coding enhances my verification, and as I said, really helps in the manual insertion process steps. And here again, this is where I'm going to extract with a great deal of flexibility in terms of how I want to define this, my XY parts list for my automated insertion equipment, okay? And as I began with just like with the assembly variants, there is a process step management tool, okay, which front ends all of the process step capabilities. So my process step manager is where I can visualize and see each of my process steps. Process step 1, chip shooter, the subgroups that make up that particular process step. But by subgroup, it's some collection of parts, depending on what parameters I've used to filter them out. And you can see I've identified the color codes there. The manual insertion step, the universal process step 2, my dip insertion, universal machine. And I have one manual insertion here. When I add or want to create a new process step, it brings me into the process step editor from the process step manager, where I can define each process step and its subgroups, okay? And I've got various mechanisms, sorry about that, I've got various choices in terms of how I want to filter those parts, and whichever one works best in my particular circumstance. And then again, once I've defined all my process steps, now I place a PCB view. Well, what do you want to do with this PCB view? Do you want it to be just a topside PCB view, or in this case, I'm going to go in and select which process step I want to show. And in that process step, since there could be multiple subgroups, what parts I want to include in this particular view. So all of the capabilities are here to create the process steps and to create those visual aids and that centroid information behind a management tool, okay? So having said that, let you digest that for a second. I'm going to leave the presentation now, and we're going to go into Blueprint and create process steps, assembly variants, and create visual aids for them, okay? And I start here with a standard document set, very basic, probably not as complex as some of the document sets that you'll create, but my basic fab drawing, my assembly drawing. I've got a top side and a bottom side on the same sheet, side view, and I've turned on some pins and so on to give some more definition to the actual view. My assembly notes, my fab notes, stack ups, drill charts, and so on. So now, what I want to do is to create some assembly variants, okay? So I'm going to go to a blank sheet, and we'll talk about all these things on here. I pre-did some things for time and simplicity. Now, as I pointed out, I have my variant manager, and right now it's empty. I've got all my parts listed here on the left, all the RD reference designators, and this is sorted by default. It can be sorted by ref des, ascending or descending. And here's where I can actually create a new assembly variant and then walk down one by one each part and say, you're installed, uninstalled, substituted, what's the substituted part? And of course, that can be very time-consuming and error-prone if I'm doing it manually, but I can do it. Instead, what we're going to do is we're going to import some parts lists, okay? And we're going to import a variant list. This is going to be a parts list, which is just for a specific variant, one by one. And this dialog appears. This is the import wizard that we talked about in the presentation. So I'm pointing to a CSV file, and I'm going to browse to it to make sure I'm pointing to what I want. And if the format always remains the same in terms of comma delimited, first row is field names, and so on, then it's point and finish, point and finish. But I'm going to walk through this so you can see, what the parts are, and Blueprint will look inside the file you're importing and match the fields to its equivalent fields in the table. Now, sometimes what we call ref des, you might call reference D, or various names. Blueprint may not be able to automatically assign that, so you'll be the one that selects the attribute that you want to assign to that, okay? When I'm done, I say finish. I'm going to do this twice because I want to bring in two parts. So I'm going to import two variant lists. I'm going to bring in one more, just so you can see how simple the process is. And I'm just going to point to a second build. I'm just going to say finish because I know everything is, in my company, everything is well organized procedurally, so the format's always the same. I've read those two parts lists in, and now what I want to do is go back to the variant manager, and there are my two parts, my two variants. And I can reorder these, but as I scroll through, you can see most things are installed. But, there's some substituted parts, and it's a different part name than what was originally there, and we'll look at that closer in a second. Some uninstalled parts. So now I have what I need. Now, you can ask, well, I have to do this one at a time for every variant? No, you don't. You can also, and I'll open this file up so you can see, you can also, and most schematic tools or ERP systems can provide parts lists in this manner, which is what we base this on. And here's somewhere, where did I put it? My master parts list. Hope this is it. Yeah, this is it. What I want to show you here is that I can actually, and I'll do this at the end of the assembly variants demo, I can read in no, it's not. No, it's not what I want. I'm sorry. Somewhere here I should have an Excel spreadsheet with all my parts. I seem to have misplaced it. But basically, I can have a master parts list, and depending on what term you want to use for uninstalled, DNI, uninstalled, DNP, you'll have columns in your parts list which reference and identify what parts are installed and what parts are uninstalled. And the only thing that has to be entered there are when a part is uninstalled. That's the key word. When you have a substituted part, Blueprint recognizes a substituted part because the part value, the part name, is different than what's in the master parts list. So you can actually import all of your parts for variants in one import. It could be 5, could be 10 different variants. It's not a problem at all. I'm really curious as to what the heck I did with that, but I put it together for the purposes of this demonstration. I'll have to hunt that down later. So now I have my variants in Blueprint. So what I want to do is create some views, just like we do for any document set or sheet. Our fabrication drawings I showed you, our assembly drawing. In this case here, let's place down a top side view and a bottom side view. And this by default, when I drag and drop that from my gallery, shows me all the top side components and all the bottom side components. And maybe I want to get a little fancy here to give us some perspective. So what I'm going to do is I'm just going to turn on, this is, my preference, I'm going to turn on the top side pins, and let's make those top side pins a hollow outline. Okay, so I have all this flexibility in my tool to create these different visual aids to help be really clear on what it is we're trying to convey. And to try and do this using traditional methods and traditional tools, obviously, is not so easy. So top side pins, advanced. So, and here's my bottom. Nope, I don't want top side, I want bottom side. Sorry about that. This is the bottom side. And here we go. All right. So, and for each of these, I also have other choices. And some of you might already be using assembly variants. For some of you, this might be new. So you may have already worked with things like our assembly variants and how to generate them and modify them. I'm sorry, our RefDes. You've been in and worked inside the PCB CAD data and all its niceties in terms of the ability to turn things on and off and set colors and visibilities in ways you may never have imagined. Here, what we're going to do is work with assembly variants, and by default, it's all assembly variants, but we can select, I'm going to select build 2 specifically because I put a substituted part in there. And when I select that, and again, maybe I want to show only the installed, or only the substituted, or like many companies do, because uninstalled is the most common flavor of variants, is they want to show just an uninstalled list. Here's my master build, these parts you don't install. Have it your way. We're going to show everything and color code it. And you can see that if I put my legend that I can drag and drop over here for this, and I'll put that down the bottom to cross-reference. Where did it go? There we go. Outline in black is installed. I could have used a crosshatch there, but I just kept it blank, like normal. Uninstalled is red crosshatched, and substituted is blue crosshatched. Let's do the same thing for the bottom side. Just come in here and show build 2. And now we have our standard, I'm not going to rescale these, which I would normally do, 2D PCB views for that assembly variant. Okay? We can also look at these in 3D. So let's just place a 3D view here. And as you can see, for the 3D view, I meant to actually edit that. Yeah. We'll give that a little spin. That's what I meant to do. We'll give that a little spin like this, just to give it a little depth. And in this case here, I'm only going to show some of the parts for that PCB. I come here to edit, and I can format that PCB view and show build 2. And I'll do the same thing here. And I'm not sure what this thing is. And I'll format this PCB view. What I want to do here, though, is go to edit the PCB. I want to view this from the bottom and go home. View this from the bottom. Go back and format this to be build 2. Everything's there. And I think the one thing I'm missing here, which has thrown me, is I don't have, for some reason, I believe, Edit the PCB view. No, all the components are there. Okay. So now I have a visual aid for my build 2. If I wanted to, I'm going to insert another sheet here. I might have a sheet before this I can use. I can actually, if you prefer, you can show a multivariant parts list. I'm going to drag and drop this up here. This might go across multiple pages. So I'm going to format this and split that at 50. We'll use maximum, we'll do, make sure we have enough space, and we'll rebuild this. And what you end up with is a variant list, which should fit on one sheet, which in this case is just 2 variants, but there could be n variants. And what we have is a master parts list, and we're showing each of the builds, and we've defined what the identifier is for installed and uninstalled and substituted, an X, a dash, and so on. So that gives you some flavors of the possibilities for assembly variants in terms of how you might want to bring them into Blueprint, how you might want to create your visual aids, manage them, display them, not only from a assembly perspective, I'm going the wrong way, but also from a tabular perspective in terms of the actual parts list. And again, we're going to do process steps now, but these combined with process steps and assembly panels is where the ability to extract centroid information in multi-dimensional ways is very, very powerful. So now I'm going to go up and I'm going to preempt the process steps by showing you a couple of visual aids I've already created of process steps, which is my process step 2 and 3, which is my dip insertion, and I've color-coded this, the visual aid, the parts list, same thing for the process step, and I've done the same thing for the manual insertion step, the part that the human being is going to do, and I've done the same thing. I've created a 2D view and a 3D view of that. This one here needs to be corrected. It got rebuilt because I want that to be the bottom. We want that to be the bottom. Okay? So there's the 2D view, and the green are the 2 parts that the human is going to install, the person on the assembly line, and here's the 2D version of that. I want to do one thing here to make sure I have this right down here. Yeah, okay. There's the problem. I was stumped for a while there, and there's the correct view of the assembly variant, bottom side, for installed, substituted, and uninstalled parts. Red, blues substituted, everything else is installed. So we've got process step 2 and process step 3 in my make-believe manufacturing flow. We're missing process step 1, so let's create that. So just like the assembly variant manager, I have a tool to create process steps, and I showed that in the presentation. And here is process step 2, and I can edit that, and you can see the dialog here. I use my component attribute template option to filter my parts, because I know that for my dip insertion machine, I need, on a particular side, all the through-hole components. And I just filter those out and put them into this process step. Same thing for my manual insertion. I know the parts that get manually inserted in the station. I filter those out, put them in this process step, and they're there for creating my visual aids. Now I've got my process step for the chip shooter, and I created that by creating I didn't need to go back, by adding a new process step. We'll call this chip shooter for short, so you can see how I did this. And I'm going to use the part type template to filter out the parts by several attributes, which will create subgroups in my process step, which I can then assign to present and include in a visual aid and a process step parts list when I'm creating my visual aids, and then leading to extracting the centroid information. And in this case, I want to extract the parts by mount type and mount side, because what I'm going to end up wanting is only the surface mount and the top side, and in the second case, only the surface mount and the bottom side when I create my visual aids. So when I create that, I'm going to ask Blueprint, you define and auto-assign the colors, but I want you to do a line color and a fill color, and I'll use solid fills, and I'll let Blueprint generate those groups, and there they are, okay? So now I have a process step called C Shooter, which mimics my existing process step, chip shooter, okay? So when I go to create now my visual aid, I'm going to drag and drop my top side, place that, if I can work my mouse. I'm going to right mouse click this, and I'm going to work with process steps now. I'm going to show the chip shooter, and it gives me all the subgroups, all the parts that are now in this process step. And I'm going to do the top side first. So I'm going to zoom in, and I'm going to turn everything off, so I can now come in and select just my top side components, okay? Here we are. And so now this is what I want to display. But before I do that, I gotta turn them all on. Oh, sorry about that. I hit the button too quick. And turn all those on. Oh. I'm not working my mouse very well here. I apologize. I'm trying to go too fast sometimes, and okay, so we're going to turn all those top side guys on, and there is my visual aid with the colors that Blueprint chose, and I can modify those colors, or I can assign the colors myself. For greater definition, I always show all components, not just the ones that are being installed here, so the person has a reference. Again, maybe some more detail in terms of routes and or pins or maybe some drills, non-plated drills, all helping just give definition to the view. So there's my visual aid for topside chip shooter, and of course I would, topside chip shooter, and maybe the step number, step 1, and I'm also going to create a 3D PCB assembly. Right mouse click this, edit it, maybe rotate that just a little bit just so I give it some depth, and go back, format it, and make sure that it's showing the right process step, and here we're going to do the same thing. We're going to turn everything off, and do the top. Almost there. And now we have the top side process step, okay? Now, in addition to that, I may want to have a process step parts list. So I'm going to place that here, and that's going to execute. And I'm going to right mouse click that, because I don't want everything. I want just the chip shooter. Oops, sorry. And here we're going to filter by the side. So I can add here component mount side equals. In this case, I'm doing the top, so I'm going to just select the top side. And there could be multiple conditions here that you want to filter on. It could be top side, only these parts, or these values. I add that condition, I say OK, and that parts list should get rebuilt. And there's my actual parts list for this particular assembly variant. What I've also done, and I can come now and I can export my coordinate list. And this brings up a dialog, and give it a file name, and then how do I want this exported? Do you want to do it for all assembly variants, master build, for this process step? Specific assembly variants, you can see the parts and the information changes here. And what process steps do you want to display? Do you want both sides of the board, top side, bottom side? You want the centroid point from the land pattern configuration or the component outline? Lots of flavors. Here, and I think that this will get demonstrated in more detail in a session tomorrow, I believe, for assembly variants. But I can get the centroid information for this one-up board, for this process step, for this assembly variant, or I can get it for the X-up board for this process step, for this variant. And I've done all that just to give you a view. Here's, for example, the chip shooter top we just created a visual aid for build 2, for assembly variant build 2. And the contents of that, which most auto insertion equipment can bring in directly, maybe some massage is needed by manufacturing engineering. But this lists all the ref des of the part type, the side, the XY locations, the angles of rotation, and so on for driving that auto insertion equipment. And I created several of these. The chip shooter bottom, chip shooter top for for assembly variant 2. I can get all variants, all process steps in the centroid information, whatever your particular preference or need is. So that's the overview of creating and managing process steps in Blueprint. Is there, Ray, are there any questions that have come up so far?
No, thanks, Joe. No questions so far. You had asked me to use this. Maybe you could just describe what you'd asked me to do with this particular demo in the panelization assembly panel.
Right. So what Ray's doing tomorrow is demonstrating the panel array, assembly panel array support in Blueprint, which is a whole nother set of functionality. What originally prompted us to this was working with companies like Qualcomm and others that were looking to bring back in-house the creation, the design, basically, of their assembly panels. Qualcomm is a good example where they have a captive manufacturing facility, and they actually do a lot of creative things like flip panels, and I didn't even cover that. So I have my master design, a one-up board. I have assembly variants. I have process steps as to how I build that. I put those boards, I assemble them in an assembly panel that goes down my assembly line. And it's X up. Well, I can also do what's called flip panels. And what I want you to imagine is an assembly panel that has 4 PCBs, 2 by 2. The 2 PCBs on the left, top side up, and right beside them, the 2 PCBs on the right, a bottom side up. So they're opposite each other. And the idea behind that is when I go down my production line and do that side, when I'm done, I don't have to shut all the machines down and retool them, or go to another line, which is tied up waiting for this side to be done so I can go do that side over there. What happens is when I flip the board over, the panel over, now I can just go back to the beginning because, again, one side's bottom side up, one side's top side up. So I can use the same setup to do both sides of the assembly panel. So you can imagine extracting centroid information for a panel, PCBs in a panel, by process step, by assembly variant, by flip panels. Can get very complex, but we can automate all that because we have all the data here, the design. We have the assembly design, assembly panel design, which Ray's going to show you tomorrow. And Ray's going to use these process steps and these assembly variants in his demo tomorrow to show how you would extract centroid information, by these characteristics, if I may. And now, many of you don't have captive manufacturing. These may not be issues for you. But what may be an issue for you is the actual, assembly panel design for cost reasons, because the more material you waste, the more expensive it is to manufacture those boards externally. So you might want to control, which many companies want to do, the assembly panel and its actual design. So you'll see that tomorrow. But you can see it gets very complex, and there's, tools have been lacking that help automate this, and that's what we set out to do. It's interesting. We didn't start when we created and had our vision for where we fit into the new product development process. Obviously, we're at the back end of it. Hence our name, Downstream Technologies, and we help bridge that space between the design world and the manufacturing world. Well, part of that challenge for companies is creating these assembly panels and extracting the information from those assembly panels in a meaningful way to drive their internal or external manufacturing processes.
Okay, I don't see any questions here. it's a bit much, especially if it's new to you. So if you do come up with questions after the fact, please send those to us. And we can always do another demo specifically for you if you have questions about what Joe went through today.
Yeah, the main thing is go ahead. Sorry, Ray.
No, go ahead.
The main thing is that for assembly variants, there's the ability to bring in parts lists from external sources, whether it's your ERP system or your schematic system. It's a much more straightforward, easy way to manage variants. And you can create all the visual aids you need for it. For those of you that are responsible in your companies for manufacturing, or do your own manufacturing, I think your manufacturing engineers would like to see the ability here to define these process steps, because they're doing this somehow. They're doing this now. And the idea, the beauty of all this is that when these these intelligent formats, be it ODB or our preference 2581 as an industry standard, these have enabled tools like Blueprint, which tie the whole process together. So, we might be really good at dealing with ECOs at the front end of the process. And I've seen this in many companies that utilize a tool like Blueprint, or utilize our tool, Blueprint, where they put this tool into manufacturing, because then when an ECO comes, and I regenerate that intelligent database, 2581 or ODB, it passes all the way down the line. So instead of being weeks behind in manufacturing, fat fingering in the ECO to update my manufacturing documentation, XY coordinates, assembly panel information, variant information, all this sort of thing, it just gets updated automatically, and everybody's ready to rock and roll right from the generation of the new design database. That's the key thing that we wanted to tie in here. It's not just creating that assembly drawing and that fabrication drawing and everything's done. There's a lot of things that happen further down in the process that we can greatly help with.
And I'll just jump in there. As you and I, when we used to travel, we would go in and demo Blueprint to a designer. A lot of times he'd go, we should get the manufacturing people involved in this. And then it's like a revelation when the manufacturing people see it. And the other side of that is we're starting to see contract manufacturers adopt, especially like the process step tools and the variant tools. So they're taking the data from you, the designer, and they're using Blueprint to create these visual aids as well.
That's exactly right. And with the capabilities of CAM 350 tied into this, because believe it, it's never going to go, even when we're gone from this planet, people will still be sending Gerbers, and contractors still get Gerber data, and they have to do all of this from Gerber data in a spreadsheet parts list. Our tools allow them to combine those things in a certain way and actually design a panel and do all the things that we've talked about here to imply intelligence into unintelligent data.
And thanks, everybody, for your time.
Thanks, Ray. Bye, everyone.